Alright, welcome back, Math 10-3. Today's lesson is the first lesson in chapter 7, which we talk about lines and angle. As you may notice, we're starting with chapter 7.2, describing an angle. The reason being is because when it comes to chapter 7.1, it is about estimating angle, and in our case, eventually, we are getting into the world of actual angle measurement. So please have that in your mind. So material, before we get to an actual lesson, you need to prepare several materials for this lesson, or this chapter if you will. You need ruler and you need compass or any circular object. I don't think you need a specific... Actually, today's portion of a lesson require protractor too. So these three geometric tools are what is important. Even if you don't have it right now, as long as you have some circular object and all, it will probably make you understand the whole process or lesson portion, concept, and skill in this lesson. The page that you need to go is workbook page 182. That is something that also I advise. 188, sorry. That's also something that I ask you to go before we start. Of course, prepare a blank pieces of paper too. I am adjusting my camera so that I can have a better room, if you will. There you go. All right. First of all, we need to review some of those basic angle. Like when people say perpendicular, and I'm going to use my rulers and over here. Perpendicular angle is generally written as square, perpendicular line, like then you should see a square or rectangle. This is always 90 degree. If you have two perpendicular angle, then you know the whole angle that you see in here will be 180 degree. And if you go entire one circle around, that's 360, because 180 plus 180, that's 360. So we need to understand some terminology before we getting into the calculation. What is this 90 facing against? What's the name of that? So on page 188, there is a diagram of crane. So if you can go, that will be awesome. If you don't have it, I'm going to copy. There you go. Only portion of that drawing. So we have A, B, C, D, E, all the way to F as a point. And we are going to learn some definition of an angle. If I look at the angle A, B, and C, so A, B, C, so this angle over here, and if I look at the angle C, B, and D, this angle. So first of all, the angle, whenever you notate, we are using 3 of a letter. We have to use 3 letter. So what I mean by that is where it start. So one end of the line, go to the middle or intersection point that have or embed that has or embeds an angle, and wherever the other line go through. So we call this angle ABC. If I try to indicate this angle over here, then I should use CBD, something like that. Some people say, Mr. King, can I put D, B, and C? That is perfectly fine too. But in any case, the reason that I point these two angles is, can you see they're exactly next to each other? Whenever we find angles that is next to each other, we call it adjacent angles. It's an angle that share a common vertex and a common arm. That's a textbook definition. In my way of explaining, it's just literally angles are touching each other and it's right next to each other. Now, let's think about supplementary angle. Now, supplementary angle, this needs some definition. Supplementary angle. Easy way of saying it is, if I add those angles, it has to make 180 degrees. So that means, for instance, if I look at the angle ABC, and if I look at angle AB and E, these two angles are considered as supplementary angle because they create 180 degree. Now, if you try to think about some of those other angle, there is one that's I don't think there is anything now in this diagram, but there is one that says complementary angle. This is another terminology that you need to know. Complementary angle says it's very similar as supplementary angle, but complementary angles are the angles that make 90 degree when they are added. Have that in your mind. So, using those brief explanation about three, adjacent angle, supplementary angle, and complementary angle, let's do some example. Using a clipboard, so please understand it. Example on page 188. Now, I'm gonna copy the question relatively in bigger scale. "90 degree, and this is angle 1. Oops. Angle 2, 56 degree, have another line that go through like this, and this angle is 46 degree. Our job is try to find the angle 1 and 2. Angle 1, what is that angle? Angle 2, what's that? As you may notice, the biggest clue that is given in here is actually this perpendicular symbol over here, because that means it's 90 degree. So if I try to find angle 1 and 2, I try to recommend to find the angle that has most of the clue. Angle 2 is good to find first, and then followed by angle 1. And I'm gonna tell you why later. First thing first, the reason that I choose angle number 2 as a first step is because I can simply subtract 90 by 56 to find out angle number 2. So, first thing first, Angle number 2 can be found by doing 90 minus whatever the given angle, 56, because they are basically complementary angles, which is a fancy way of saying they added up to 90. That's why I can use that. If you want to use if you want to use your calculator, feel free to take it out. If you want to use your mental math, feel free to. But 90 minus 56 give you 34 degrees. That is my angle number 2 over here. 34 degrees. Now, number 2. If you think about the whole angle from line on the right all the way to line on the left, you may notice that this is 180 degree because it's a whole 90 and 90 together, or start and end to the opposite side. That's 180 degree. So that means if I want to find angle number 1, I can just do the same thing. 180 minus the adjacent angle 56 minus angle number 2 that we found, 34 degree minus 46 degree will give me angle number 1. So 180 minus 56 minus 34 minus 46 will provide you 44 degree. And ladies and gentlemen, that is basically how you solve it. And the reason that I could solve this angle number 1 is because everything added up to be supplementary angles. And because they're supplementary angles, they all made out to be 180 degree. That's one of the lessons. Now let's go with chapter 7.3. The title of the chapter 7.3, ladies and gentlemen, is Bisecting Angle, which is a fancy way of saying whenever you see the word bisecting, cut in half is what it is. Mathematically, that means divided by 2. So you are basically bisecting an angle. So here's what you need to do. You're going to learn 2 different skills. And you should have learned this in junior high a little bit. So for some people, it's a little bit of skill that you can remember. And by the way, I'm not using any of textbook example for that. I'm just going to do classic example on any paper. So have that in your mind. The first skill that we are going to learn is perpendicular bisector. So that means we are going to make 90 degree. How can we make that? Well, first thing first, I want you to create any of a line. I'm gonna use a horizontal line for the first. I'm gonna call this dot A, B, so we know that line is created A and B. Your first step is basically using a compass. I have my funky compass and I'm going to take this page off from a clipboard because clipboard will be on the way. So here's what you need to do. I want you to put one of the end of the compass on one dot. Control my radius of a compass. If you use a traditional one, it looks like a V shape. So you put one of the pointy end and you're controlling the one that you can attach your pencils with. And here's the thing. Can you see that I'm moving it past the middle point over here? And that is a key point. The reason being is because in that way, I know it's gonna get a little messy, but can you see that my circle passes the midpoint over here? And that's the key point of our skill for the perpendicular bisector. If this circle is smaller than halfway, we cannot do this. So bigger the circle, the better. Now, another thing is, gonna make a same sized circle on the other side. And now, can you find that I have an intersection point over here and I have an intersection point over there? Now what you need to do is basically connecting those lines together using a ruler. As you may notice, it goes a little bit beyond of my title, so I'm just gonna stop over here so that it doesn't interfere our line. Now here's the thing, C and D. As you may notice, I have a perfect perpendicular angle that's coming out, and the reason it's called perpendicular bisector is because 180 degrees divided into 2, that's 90 degrees, and at the same time the length between A and this intersection point and this intersection point to B, those lengths are equal length. Those are called perpendicular bisector. So now, step-by-step portion, I am going to write down those steps in here. Number 1, draw one circle, and it doesn't have to be entire circle or semicircle. And that's a first step, but the caution that you need to understand is circle side should exceed the midpoint. And that involves a little bit of estimation skill, but it's relatively easy to do. Number 2, draw identical sized circle or semicircle, basically on the other end. And number 3, connect intersection points together. That is basically the 3 steps you need to do for your perpendicular bisector. Let's do one more of perpendicular bisector. Create some randomly like this. This time, let's call this line C and D. And you're trying to find perpendicular line from this line segment C and D. So, first thing first, locate the center and then control your arm of the compass, and then I want you to draw a circle. A semicircle will do the trick too, like what I mentioned. As you may notice, I am passing the midpoint to draw big enough of circle. Just gonna bring this up a little bit because my hand constantly bump into the diagram. I don't know how good this will turn out, but in any case. Now, second step, identical circle, except you have to draw on the opposite end and make sure you're not changing the size of the arm. Voila. Can you see my intersection point over here? I'm gonna call this E, call this F, And once you connect those lines together, there you go. I just created perpendicular angle. And the length between C and the midpoint to D, they should be identical length. This is perpendicular bisector. Now our last lesson, which is number 2 skill, angular bisector. When it comes to step, I'm not gonna write down each of the steps because steps are given on page, what is this page? Page 190. So I'm rather going to do a quick example. And the example that I'm gonna do is, why don't we bisect 90 degree? And it doesn't matter. It can be any type of other angle too. So second example, I'm not gonna do perpendicular. A, B, C. So angle ABC is basically 90 degree. Angular bisector is like the word that is being used. You are basically dividing this angle by 2. Now, one thing that you need to do is, can you see this midpoint or intersection point that is embedding 90 degree? That's where you need to put your compass. And fortunately, the circle size doesn't matter. You can create, there you go. You can create any size circle as long as it's good enough to pass the midpoint. So let me just confirm my drawing. There you go, that's better. That's your first step. Create any type of circle. Now, after that, what you need to do is, can you see this intersection point at the line segment BC and AB? That's where I need to move my compass and then draw identical sized circle. Hopefully this doesn't hit. Does hit a little bit, but whatever. And you may notice that I'm drawing semicircle, and that's okay. Do the same thing on the other side. And can you see this intersection point over here? I'm gonna call this point D because that's what we need to put a line through the center all the way to the end. That is my angular bisector. So step 2 and 3 is basically creating another circle from the point between B and C and the same point AB, and we are creating another circle. Make sure it's identical circle, then you will get this intersection point D, and we can connect these 2 points and extend the line. This is angular bisector, and you may notice that 90 degrees is what we have. So if you divide this by 2, what will be the angle? That will be 45 degree. So this is 45 degree, and that will be my 45 degree. Let's do one last example, and this time gonna create some angle that is other than 90 degree. And in fact, I am going to check it using my protractor. Using the protractor, I know that this is my horizontal arm. It's 30 degree. See, and I can say angle CDE is 30 degree. That means if we do angular bisector, we should have half size of that angle, which is 30 divided by 2, that's 15 degree. So let's do this. Create a circle, have to pass 2 line segments like this. Don't change the size of the radius, but now relocate it between the horizontal DE line intersection point. Create a circle, part of a circle if you will, and then do the same thing for the other intersection point. And this X-shaped intersection point, which I'm going to call F, is the one that I need to connect with line D. That's what you need to do. And the angle of EDF should be around 15, and let's check. And oh boy, there you go. As you may notice, if I put my horizontal part and vertical part completely, that's 30 degree, and look where my new line goes. That's between 10 and 20. That's exact 15. So angle EDF, it's 15 degree. Angle CDF, it's also 15 degree. And that's what today's lesson is about. Your to-do list is quite simple. Do all question on page 189. There's about 3-4 example, and page 191. Also all of them, please. There's about 4 or 5 questions. So it actually doesn't take a long time for these 2 sections. So I want you to give it a shot for those.